Okay, regardless of what problem you guys are on, let's just take a look up at what we're doing, and I'll give you guys some hints or clues as to how we could, make some good educated guesses if we are at that point. So for problem 16, it says in 2015, the population of city X and Y were equal, and from 2010 to 2015, the population of city X increased by 20%, and city Y went down by 10%. City X and Y, or City X was 120,210. Lots of information there. So I'm going to try and be systematic about this. Let's say that's City X and City Y. And we're talking about really two different time frames. We're talking about 2010 and 2015. So let's first start with any solid information that we know. City X had a population of 120,000 in 2010. So that's 120,000. Okay. Now we also know that, what do we know? That city X and Y were equal in 2015. That means that down here, they're going to be the same number. So hopefully we can figure out one of those numbers. Well, we can because we know that city X increased by 20% in that time. So this is a calculator problem. We could do 120,000 times 1.2. Okay, so if we do, or we could, without your calculator, figure out, well, let's see, 10% would be 12,000, 20% would be 24,000. Add them together, we get 144,000. But of course, your calculator would nicely give that to you very quickly. Now remember that their populations are the same. So that's 144,000. And what we're really trying to figure out, what was the population of city Y in 2010? All right, so we're trying to figure, this out. Well, it said that city Y decreased by 10%. That bit of information is really important. If it went from here to, if that was a decrease of 10%, this number must be bigger than 144,000. So it cannot be A or B. Okay, it has to be bigger than 144,000. So now you could figure out, all right, well, which one decreases by 10%? Try one of them. If that doesn't work, the other one has to be the answer. So, I'll try 240,000. 10% of that would be 24,000. And 240,000 minus 24,000, that's not going to work. So the answer is C. Or if you tried 160,000, 10% of that would be 16,000, and 160 minus 16 is 144. Okay, so organizing is really a big deal for that one, being able to come up with your own chart. Problem 17, this is an old algebra problem. Okay, just working with variables and doing some algebra manipulation here. So which of the following gives the radius in terms of the volume? That meaning in terms of volume, that means you are going to solve for the radius, and we're going to have a V somewhere over here on the other side. Okay, so we're solving for the radius. All right, so sorry, let me go back here. Taking this equation, V equals 4/3 times pi times r cubed. Well, the first thing we want to do is we're trying to get this by itself. So I'll multiply both sides by 3/4. So that's 3V over 4 is equal to pi r cubed. Now I'll divide by pi, so I get 3V over 4 pi equals r cubed. So I'm already in my head starting to eliminate some possibilities over here. I take the cube root of both sides, and so I get the cube root of 3V over 4 pi. All right, next one. The table above shows survey results, and lots of this stuff, guys. Again, just trying to be able to figure out the information from the chart. So based on the table, which of the following is closest to the probability that a tablet user answered always, given that the user did not answer never? This part is pretty interesting. Okay, what that means is we're throwing out the never data. And what we want to do is we want to figure out the probability of somebody doing always over all of the other ones. So we do 30.9% divided by these three added together, divided by 30.9 plus 13.5 plus 24.3. And that's going to give us our probability. Probability is, winners over total, essentially. So that's a great calculator question. This one I definitely would use a calculator. In fact, I think I might have even typed it in. I did. So I already typed it into my calculator. I get 0.4497, which means my answer is 0.45. All right, last but not least, number 19 is a quick one. I love quick ones. When you are able to just look at it and say, all right, parabola opening downward. Can you visualize that like that? So I know that it has a maximum. If it's a parabola that opens downward, it has a maximum. So the answer is either C or D. Okay, because it's upside down. So now that parabola is going to move to the right 3 and up A. So I got a parabola going to the right 3 and then up some amount. It's opening downward. And so its maximum is going to occur at to the right 3 and up A. All right, and as always, your answers are down in the bottom right. You can always check those. You guys have any questions for me?